Hello and peace be upon everyone. Welcome to my channel. So today we're going to be working on organic chemistry, which involves us to assign R or S configuration to a chiral center. So this video is going to be intro and also um it's going to follow some particular objectives. So if you would like to watch just the practice, make sure you look at the chapters under my video and just skip to that. But for students who are really understanding the introduction, please watch all of this because it's very, very necessary. So, now the first thing I wanted you guys to know is that we're going to go through a couple of objectives. The first one would be to learn chirality and chiral centers. For example, what is the concept of chirality in terms of structures? What makes something a chiral center, and then what makes something an achiral or non-chiral center. So the next thing you have to do is I'm going to teach you steps and tips for determining chiral centers um configuration. First of all, I'm going to give you the breakdown information, and then I am going to work with you guys to do a bunch of practice problems, at least 10 of them. And by the end of the video, you're going to be able to know a lot more about R and S configuration of chiral centers. So really it's either R or it's S. That's it. And then the last one is going to be me explaining configuration of non-chiral centers or chiral molecules. And by the time we're done with all of this, you're going to learn a lot more. The first thing I want you guys to know is that whenever you're dealing with um chiral molecules, you have to know that there is something called a chiral center that has to exist. A chiral center is a center that connects four different substituents to that basically connects four different substituents. So in this particular case, A here is the chiral center. It is the chiral center mainly because it has four different groups. It has B serves as one group, C serves as another group, D serves as another group, and E serves as another group. All four different groups. And whenever you're dealing with chiral structures, they always have to be tetrahedral. So you have four different groups of four different substituents attached to it at all times. Now we're going to start filling it. You see that the chiral center in this particular situation is A, and the reason why it's a four, it's a chiral center because it has four different substituents or four different groups attached to it. And the substituents in this case are B, and then C, then D, and then we have E. These are the four different substituents. Now, the next thing is achiral molecules. Achiral molecules just are molecules that do not have a chiral center. And when they don't have a chiral center, what that simply means, honestly, is just that there are two things that will make something achiral. It is that the molecule has a plane of symmetry, right? Plane of symmetry. Plane of symmetry is a plane, or you can think about it as a line that separates two things. So, for example, this molecule has a plane of symmetry um, because this molecule has like a line, an imaginary line, where the right side of the structure and the left side of the structure are exactly the same. So whenever you're dealing with chiral molecules, you do not want them to have a plane of symmetry. The second thing you wouldn't want chiral molecules to have, or the second thing that makes a molecule an achiral molecule or a non-chiral molecule, is also that you don't want them to have the same the same substituent, like two or more substituent that are the same, that are attached to a chiral to a center, would cause the molecule to be achiral. So in a situation where, for example, let's redraw a similar structure. You have A, you have B, you have C, and then you have D, and then you now have a C again. This is going to make this molecule achiral because you have two or more of the same substituent. So in a situation, for example, where you also have, instead of a B here, say you have a C here as well, it's gonna make it achiral. So two or more of the same substituent, or two or more of the same type of group attached to a center would make the entire molecule a chiral, as well as the plane of symmetry. So I just want you guys to know that when you see a molecule and you're supposed to determine, for example, the chirality or the achirality of a molecule, check. Does it have a plane of symmetry? Yes, if it does, it's not a chiral center. Also, you could also check, does he have what they call it? Does he also have two or more of the same type of substituent or group? If it does, it's also not a chiral molecule, hence it's an achiral molecule or a non-chiral molecule. So hopefully that teaches you guys. Now we move to the next part, which is to learn the steps to assign R and S configuration to a chiral center. The first thing you have to know is that we do not assign R slash S configuration to the molecule. We only assign it to the center. So, for example, in a situation where there's like more than one chiral center, you're gonna have two different configurations, right? That's just basically how it works. Now, let's go towards the steps. The first thing you have to know is that anytime you're asked to determine whether chiral center is R or S configuration, you first of all have to assign priorities to the four different substituents based on the atomic numbers. So, for example, the atomic number of um, the atomic number of the highest would have the highest priority. So, or the largest atomic number. So, if the largest atomic number is for an atom that has 52, and there's subsequent atoms that have like 40, 38, 17, the highest atomic number would receive first priority and would be labeled first. And then the second highest atomic number will have the second highest priority. The third highest atomic number will receive the third highest priority. And then the lowest atomic number would be the one that has the least priority. So let's come here now. You have a situation in this particular case where you have F, you have first of all C, carbon, and then you see is attached to fluorine, oxygen, iodine, and chlorine. Now, iodine, if you look at your periodic table, has the highest or the largest atomic number, so it has the highest priority. And then you have chlorine, second largest, and then you have fluorine that has an atomic number of 9, and then you have oxygen that has the atomic number of 8. So it will have the fourth highest priority. So iodine, chlorine, fluorine, and then oxygen. That is how basically the priority is set, right? That's the first thing. Now, the second thing is you have to draw a circle from 1, 2, 3, 4. So we're going to draw a circle going from 1, 2, 3, 4, and you see that the iodine comes first. So we start from the iodine area, and then we have the chlorine area, and then you have the fluorine area, and then you have oxygen area. So the circle is going this way, right? It's going towards this direction. So you have to start and you draw it. And then the third thing will now be if the lowest priority group, meaning the fourth, is pointing away from you. Now, one thing you guys need to know is that you see this wedged line, or yeah, this one. Basically, do you see like the well shaded one? Anytime you see this in organic chemistry and you see an atom, this is telling you that the atom is coming to your face, it's coming towards you. If you see this, basically this right here, and you have this, that is telling you that the atomic is going away from you. So coming towards you, it's like a three-dimensional structure where it's coming out of the screen of your phone or your laptop or out of your notebook towards you, facing you, coming at you. Then this like dashes is telling you it's going away from you. So it's going out of your, it's going into your book, going into your screen, and that's it. It's not coming towards you, it's going away from you. So that's, you need to know what that means. So if the lowest priority group, the fourth one, is pointing away from you, that means it's going backward. Then R is clockwise, and then S is counterclockwise. So what this is just basically saying is this: we look at what we have, we see that the lowest priority group is O, and we have this lines here, which is showing us that O is away from us. in a situation like that, what they are telling you is that um if this is the situation, whenever you have clockwise it is R, whenever you have counterclockwise it is S. So now we have to check. We'll see that it was going in a direction like this. It was going this way, and this way is what you call clockwise. So this is gonna have an R configuration because first of all, the first thing we did is to assign based on the different constituents with priorities based on their atomic number, one being the highest and then four being the least. So we did that. I'm so sorry. Uh, we did that right here, right? We did that right here. And when we did that, the next thing we had to do was we drew a circle from one to three, and then we did that. We also assigned the fourth one, which is basically the last one. And then we saw if the lowest priority group four is pointing away from you, that means it's going backwards, then R is clockwise and then S is counterclockwise. We saw that oxygen is the lowest priority group, is actually going away from us. And then what we end up with is a clockwise one because the circle was just going this way. So clockwise is going to be R and then anti-clockwise would be S. Now we're going to repeat the same thing process, right? We're just going to do it. Please put in your notes. You have iodine first priority, chlorine second, fluorine third, and then oxygen fourth. And then they said we should draw a circle, right? That's the number two. Draw a circle, one, two, three, four. So we go this way as we join the circle. Now we're going to see what they said. If the lowest priority group is pointing away from you, going backwards. Now, the lowest priority group is actually oxygen, but it's not going backwards. It's not going away from us. It's actually coming to us and it's coming forward. Then, what is the next thing you have to do? We have to go to the next slide to see if the fourth group is pointing towards you, right? Or the lowest priority group is coming forward, then the configuration reverses. So normally, if it is supposed to be an S configuration, you reverse it to get an R, and if it is an R configuration, you reverse it to get an S. So we see this. We see that the circle is actually going in a clockwise direction. We actually like that it's going into clockwise direction. But then we look at the fourth priority group after we've drawn the circle, and we see that it has this really shaded one, and this is telling us it's coming to in front of us. So what we have to do is, since we know this is an R configuration because we did it on the left, we have to reverse it and this becomes an S configuration. So the configuration of this chiral center is S. So let's just rewrite it here. The configuration for this one, right, reverses from R to S. So the configuration of this one is just S. And then the configuration on the one on the left is R. So that's just basically what it entails. That's literally what it entails. If we had an S situation, we go to R. If we had an R situation, we go to S. That's how you just do it. So now I've explained to you how that works. Now we are going to do a bunch of practice problems that a lot of you have been dying for. So the first thing you remember we do, what do? We assign priorities to the four different substituents. We see that iodine is the largest, so that's going to be number one. We see that bromine is number two, it's the second highest atomic number after iodine. And then we see fluorine is the third highest atomic number. And then you have our best friend, which is the fourth, which is just hydrogen. So we have to go one, two, three, wherever way it goes from one to three. So if we go this way, it's gonna be wrong because that means it's telling us that it's going one, three, two, but we don't want to go through one, three, two. We want to go through one, two, three, the way it was explained. So we're gonna have to draw a circle from one, two, and three, and doing that is going to look like this. It's gonna be going this way. So one, and then two, and then three. So it's going to be going this way, counterclockwise direction. And what we end up with going this way is going to tell us that it's an S. But before we can agree that this is our final answer, we have to check the third information, which says, is this hydrogen the fourth priority? Is it going outside or is it going inside? Well, it's going outside, going away from us. And whenever we have it's going away from us, we are going to look at it. Is it clockwise? Is it counterclockwise? Well, since we don't have a situation where there's going to be a reverse, we're going to stick to the answer being an S. So this is the answer is going to be clockwise, which is going to have an S configuration. So the chiral center in this particular question is S, just like we did it before. So we have, first of all, did the priority, then we drew the circle, and then when we did that, we determined that the fourth priority is just going to be um going out of the page, going away from us. So that means the clockwise is R, but we had the counterclockwise, so we're going to determine it to be S. So now we go to the next question. And the question is this particular one. We're supposed to determine the chiral center configuration. And the chiral center is this particular carbon here. Now, the first thing we do is we're going to assign the priorities based on the largest atomic number. The atomic number of nitrogen is 7, and the atomic number of the carbon here as well as the carbon here. Of course, hydrogen has the lowest atomic number, so it's not going to have first priority in any way, shape, or form. So you see that atomic number is 6, and then nitrogen is 7, so this is going to be first priority. Now we're in a situation where we have a carbon here and a carbon here, and we are supposed to determine which one of this is going to have the highest priority. Now, this carbon here is just basically a CH3, it's a methyl group. The carbon is attached to three hydrogen groups, and hydrogen atoms are very small, and they also have like lower atomic numbers. Now we have in this case, this is attached to another carbon group, and then this is called a CH3, and then this carbon here attached is also attached to two hydrogen atoms. So this entire group is what you call an ethyl group, which is just basically CH2 CH3. CH2 CH3 is going to take priority in comparison to CH3 just because it has more substituents attached to carbon, and those mini substituents actually have a higher atomic number. So it has like another carbon group attached, and this one is just attached to three different hydrogen groups. But instead, ethyl is attached to a carbon group and two hydrogen atoms. So this is going to be of higher priority. So that's something you guys need to know. Not all questions will look the same. There'll be certain questions that you're supposed to like think outside the box for, and this is one of them. So you have this one taking the second largest priority after this, and then of course this is going to be the third, and then this is going to be the fourth. So the next thing that we were taught is that we have to draw a circle going 1 2 3, right? So we start from here, 2, and then 3, so it's going 1 2 3. Then the third step is we have to check if the lowest priority group, fourth group, is pointing away from you, basically pointing away from the page, going into the page, going backwards, then R is clockwise, and then S is counterclockwise. Well, the H is hydrogen, right? It is basically pointing away from me because it has like this basically this lines. It's not like a sharp shaded wedge, so it's going outside, it's going away from us. So now we already know this information. Now we're going to think, so this is going this direction, making it clockwise. So what we end up here is that the configuration for the chiral center has an R configuration, and that's basically the answer to this question. Now the next one is this one, and you have our beautiful carbon center, and then you have a CH3 group, right? And then you have hydrogen here, and then another hydrogen, and then you have another CH3 group, right? This other CH3 group. So basically, This is attached, one of the attachments, one of the attachments, one of the attachment, and then this is the last attachment. This entire thing here is the ethyl group again, which is just CH2 CH3. So two hydrogens attached to this carbon here, as well as a methyl group. So this is also going to take priority, just like we did in the previous one. So this is going to be one, and then this is going to be two. This carbon here is going to be the second priority, and then this will be the third priority, and then we have the hydrogen, the fourth priority. Now the next thing we have to do is to see whether our hydrogen has a wedged line, meaning like, or do a dashed line. In this particular case, we see that we have like the one pointing away from us, so it's going into the screen or going into your book. So when we have that, we're now going to see whether it's R. If it is R, that's a clockwise rotation. If it is S, it is an anti-clockwise rotation. So this goes from this direction, from one, and then two, and then three. Our circle is going in the clockwise direction, and clockwise direction for this, since the fourth priority is going out of the page, is going to be an R. So this is an R configuration. Then this is just basically the answer. Now we move on to the next question. We have this one. We have the chiral center here. The first thing we have to do, of course, is to assign priorities based on the atomic number. Nitrogen has a larger atomic number than anything, than any of the other three priorities. And then number two is going to be this because it's an ethyl group, right? And then number three is going to be here because this is a methyl group, CH3. And then number four is this. So when we've gotten this, we were going to start drawing a circle. So we're going this direction from 1, 2, and 3. Now, before we can determine if it's S or if it is R, we are going to look at this one here. We see that the hydrogen is pointing towards you, towards me, basically coming out of the screen, coming out of the page of your book. It's coming out. Whenever we have a situation like this, if normally we're going towards the R direction, which is the clockwise direction in this particular case, which is what we're gonna go with. But because of we have a situation where the fourth priority is coming out of the page, basically coming out of the page strong or coming out of the screen, it will go from R, which is the clockwise, to the reverse, which is the counterclockwise. So our answer is going to be S because S is the counterclockwise, is the reverse of a clockwise. So really we're gonna be putting the we're going to be switching from the R to the S. So the configuration, even though it's going clockwise, we're going to assign it an anti-clockwise configuration. So this is the answer to this. I'm sure you guys are smart enough to pause the video and learn. Make sure you're doing that honestly, because you need all the help that you can get. So use your time effectively. So the next thing you have is this particular question. You have OH, then you have hydrogen. Now, because I've been using ethyl methyl too much, I'm going to switch it up just so you guys don't think that's the only thing. So we have methyl. Well, we're going to turn this to an ethyl group, and we're going to turn this to a propyl group. So you have this structure instead. So you have this. You're gonna see that it's not really doesn't change much. I just want you guys to have diversity of examples. So you have the chiral center for sure, which is this one. And the reason why this, of course, and other ones are not chiral centers, because you have hydrogen here. The imaginary hydrogens are always attached to a carbon chain. The same thing here. So of course, if you have two of the same type of atom, this cannot be a chiral center. But in this case, you have an ethyl group here, which is just CH2, right? This is a CH2 part, and then this is a CH3 part. So that's ethyl. And then in this case, you have a CH2 part here. And then, of course, it's another CH2 part. And then you have a CH3 part. So you have CH2, CH2, CH3. And yeah, so I'm just letting you guys know that that's the reason why this other ones that I'm about to shade in blue are not chiral centers because hydrogen, they have more than one of the same substituent. So the real chiral center is just the one shaded in purely red. This middle here that has like the red one. So now we're gonna start assigning priorities just like we've been doing. Atomic number of oxygen, of course, is 8. We have two carbons here, and we're gonna assign priorities. Well, CH2, CH2, CH3 has more of the carbon chain. It has more carbon chain. You can see and it has more carbon chain and a greater like mass of substituent. So we're going to make this particular place number 2 priority, and then this one, the ethyl group, is has lesser than the propyl group, so this is going to be put as 3. And then of course hydrogen is going to be the 4th priority, so we are going to go in this direction. So before we now determine whether it's S or R, we're going to look at the 4th priority. We see that the 4th priority is coming towards us. It's coming out of the page or out of the screen in front of us. And because it's doing that, oh my gosh, we have to reverse whatever um our configuration is. So of course, since it was going to counterclockwise direction, we're going to get an S. But because of the least priority is coming, the hydrogen atom, the least priority is coming towards us, coming out of the screen, and all of that case, we're going to be in a situation where we have to reverse. So R is the answer. So for this, the answer is that this chiral center has an R configuration, and this is basically the answer. Now I'm going to give you guys and show you guys something beautiful. So remember when I was teaching you guys at the beginning that there is something called we're going to be determining and learning the configuration of chiral molecules as well as achiral molecules. Now I'm going to like teach you something new here. A great tip is you see this question, right? This is definitely not a chiral center because it has three hydrogens attached to this carbon. This is also not chiral because two hydrogens that imaginary attached. We're not basically it's not in the structure. We can see it, but it's in there in the molecule. Then you have two hydrogens, of course, and then this case too, three hydrogens, and then this one has hydrogens. You guys have been tempted to make this one a chiral center, but then remember what I told you about it. Chiral molecules are the ones that can have chiral centers. Achiral molecules cannot. There is a plane of symmetry right here where this side here and this side here are the exact same. They're mirror images of one another. And chiral molecules cannot have a plane of symmetry because they become achiral. Another way for you to have determined is because this group here, this ethyl group here, is also the ethyl group here. So you have the substituent attached to the carbon. This is the carbon is of course the center, right? And so the substituents attached were actually hydrogen, and then you have an NH2 group, and then you also have two ethyl groups. So two C2H5 groups or CH3 CH2 groups. So because we have two of the same group, this is also going to make it a chiral molecule, besides even the plane of symmetry. But yeah, that's just what I want you guys to know that is going on. So because of this is an achiral molecule, achiral molecules do not have a configuration. So it's neither R or S because it's an achiral molecule. So that basically um goes on to explain what I tried at the front. You remember configuration of non-chiral centers? Achiral molecules, non-chiral centers do not have a configuration of either R or S because in order for us to be able to determine the configuration, we need 4 different substituents, which achiral molecules do not possess. So that's a good tip for you guys. So none. So now we are about to start this one. Um, the first thing you have to know is that these two molecules are the exact same. We're going to first of all focus on this first chiral center, which we're going to label A, and then we go to the second one, which we're going to label B. So for the A part, which is like the left side that we're going to start with, you can see that the chiral center for this particular one um, is attached to bromine in a wedged form. So you have this, that means the hydrogen that we did not write is just basically chilling somewhere, which is just hydrogen using the dashed form. And in this case, we would have to, like, first of all, prioritize, right? So we're going to put one for bromine. And now we're in a situation where we have this carbon group, which is the methyl group, the CH3 group that we've been seeing from the video. And then we have this entire carbon group. And we have to determine which one of them will take priority. So this CH3 group has much less like atoms attached to it. The atoms are attached to the carbon here is just three hydrogen atoms. And then in this particular case, the atom attached to this carbon here is one chlorine atom, also one ethyl group, right? As well as one hydrogen atom. You can see that the atomic mass of the chlorine, as well as the ethyl group, as well as the hydrogen, is all greater than the three different hydrogens. So this particular one right here would take the second priority just because there are more substituents in the carbon chain that have like greater atomic mass. So even though this is carbon, we looked at what else is attached to this carbon, and we saw that the what was attached to this carbon that is taking the second priority has much more atoms with greater atomic mass in comparison to the three hydrogens that is attached to the three hydrogens in the methyl group. So of course hydrogen is going to be the lowest, so methyl group is going to take third priority, and then the fourth priority is going to be the hydrogen. So we're now in a situation where we have identified and we have prioritized all four groups. And now remember what we're going to do. We're going to trace it. We are going to trace it. So bromine going, and then we go to 1, 2, 3. So 1, 2, 3 is giving me the counterclockwise vibe. I don't know if we can say that in organic chemistry, but that's basically counterclockwise, right? Because it's giving counterclockwise, this is going to be the S configuration. But of course, we have to now make sure that we don't have a situation where there is a reverse configuration. So we see that hydrogen is the fourth priority, and it has a dashed form, meaning it's going backwards, because it's going backwards away from me, away from you guys, away from the book, away from the screen. So that means we're going to stick to this, and there is no situation of reverse. And the configuration of the chiral center A is going to be S. Now, the next one is we're going to do the chiral center B. And you would notice that this particular molecule, of course, has two chiral centers. I'm going to show you what else to do with it, like on the next slide. There's one like bonus tip I need to tell you guys. So before we go there, let's do the second one, right? So the second one is chlorine. Is this chiral center B is attached to chlorine atom, is attached to ethyl group, is attached to this particular group, which is also called the carbon group, attached to bromine, attached to another methyl, and also attached to a hydrogen. And then we have this gorgeous hydrogen just chilling at the back because chlorine is wedged in front of us, so it's coming forward. So knowing and using the rule of atomic number to prioritize, we know chlorine has the largest atomic number, and then we have this carbon atom attached to this carbon here, as well as this carbon. This carbon here is ethyl group, is attached to CH2, right? It's attached to two hydrogens, so this whole thing ethyl CH2 CH3, while this one right here, carbon is attached to um hydrogen, okay, is also attached to a CH3 group, and is also attached to a bromine group, while this one here is just attached to the carbon here is just attached to one hydrogen group, another hydrogen group, and then another CH3 group. And you can see from the left hand side that the atomic mass, or sorry, atomic number of what is on the left hand side, all of the substituents, the secondary substituent basically have more atomic number. So it's just basically bigger. So we're going to prioritize what is on the left hand side. So this is going to be priority 2. And then the ethyl group, of course, CH2CH3 is priority 3. And of course, our gorgeous hydrogen is going to be 4. So since that is the case, what you end up with is is this situation here, and we're going to draw, right? So we're going to start from 1, and then we're going to continue to 2, so 3, 4. So the circle is basically going in this direction from 1, 2, 3, 4, and this is basically telling us that it is counterclockwise. But before we can like agree as to whether like this is actually sorry, before we can like agree as to whether like this is counterclockwise or not, we have to check the configuration of the fourth priority, which is hydrogen, and hydrogen is dashed. So basically it's oriented backwards and chlorine is oriented forwards. So since hydrogen being the least amount is at the back of the page, at the back of the screen, going away from us, going backwards, then we know that we can stick to it and we don't have a situation where we have to reverse. And then counterclockwise will also be S. So configuration for both the chiral center A as well as the chiral center B are both S configuration. Now we've reached the point where we can start wrapping up. I'm sure like what I've taught you so far has been um like of added benefit. I wish you guys all the very best. But one thing you need to know is this: if you're given a molecule and you're able to identify that the molecule has n number of chiral centers. So imagine the chiral centers or number of chiral center equals n. In order for you to know how many combinations of configurations, how many combinations of configurations, we use this formula. Okay, formula 2 raised to power n. So for example, now let's use the past one. The past one we had chiral center A and chiral center B. So we had basically 2 chiral centers. Like the number of chiral centers were 2. So chiral center number, okay, so that would be 2 raised to the power of 2 is 4. So you have 4 different combinations, and these are the 4 different combinations. You see that you can either have RR, okay, RS, okay, SR, or SS. And of course, we got SS for both of the chiral centers. It could have been RR, it could have been RS. RR and RS are opposite, and then RS and SR are also opposite. So these two are opposite, and these two are opposite. So let's also try for something else, right? Let's try for if we had 3 chiral centers. So that would be n equals to 3. So that would be 2 raised to the power of 3. 2 times 2 times 2. That is 8. So that would mean we have R, 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 S, R, R, S, S, okay, R, R, S, or we can have S, 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 R, R, okay, S, R, S, and then SSR. You can see that these are the 8 complete ones. So I'm just letting you guys know, in case like you're in a situation where you have to do this, just know that like these are the different combinations or that you can get for chiral centers within a molecule. But of course, if it's just one chiral center, 2 raised to the power of 1 is just basically 1. Sorry, 2 raised to the power of 1 is just basically 2. So it's either R or S, which is what we've done in previous examples. So this is basically the end of the video. For anyone who is still here, make sure you watch more examples on stereochemistry on my channel. and make sure you put whatever you would like in the description box so that I can know like what other materials you guys would like me to cover. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh. Assalamu alaikum.